Good day everybody, we got an interesting question. We are expected to integrate integral square root of 1 positive x squared times dx. So foremost what I wish to do is I would like to make the following substitution. Let x be equal to tan theta. Differentiating, I get dx is equal to differential of tan theta is secant squared theta d theta. So this can be rewritten as integral square root of 1 positive tan theta raised to the power of 2. In place of dx, I will be substituting secant square theta d theta. So this is equal to integral root of 1 positive tan square theta times secant square theta d theta. I know a formula, secant square theta negative tan square theta is equal to 1 and secant square theta is equal to 1 positive tan square theta. So this is equal to root of secant square theta times secant square theta d theta. Square root of secant square theta is secant theta times secant square theta d theta. Multiplying these two would give me secant cubed theta d theta. Now this itself is a challenging question. Now what I wish to do is I would like to show to you how to integrate this. Right, now let me go to this new page. So let I be equal to integral secant cubed theta d theta. Now I wish to write secant cubed theta as secant theta times secant square theta d theta. Now I would like to make the following substitution. So we would be utilizing integration by parts. So for that, uv negative integral v du. So that is going to be the formula that we would be using. So it's going to be u times dv. Now u is taken to be as secant theta and dv is taken to be as secant square theta d theta. Now differential of u is du. Differential of secant theta would give me secant theta tan theta times d theta. Integrating this would give me v is equal to integral of secant square theta d theta. Integrating this would give me tan theta. Okay, so with this we would be substituting the information in the integration by parts formula and then we would get the output. Now you might be wondering, if u is equal to secant theta, how did I get this? Just to give you some insights, I'm going to take u as secant theta, but secant theta is nothing but 1 over cos theta. Now we can apply integration, or I should say differentiation by quotient rule. So if we were to differentiate this, u dash is going to be cos theta times differential of 1, that's 0, negative 1, differential of cos theta is negative sin theta divided by cos theta raised to the power of 2. That's a formula for quotient rule. So negative negative positive, so you get sin theta divided by cos square theta. This can be rewritten as sin theta over cos theta times 1 over cos theta. Sin theta over cos theta is tan theta, 1 over cos theta is secant theta. So I can rewrite this as secant theta times tan theta. That's the reason I got that. Now coming back to this one, how did I get integral of dv which is equal to integral of secant square theta as tan theta? So I'm going to show that also to you. So we got secant square theta. Now is it okay if I write secant square theta as with this formula? Now secant square theta negative tan square theta is equal to 1. So from here secant square theta is equal to 1 positive tan square theta. So what I wish to do, I will be writing in place of secant square theta 1 positive tan square theta. So this is going to be 1 positive tan square theta times d theta. Now we can always write tan squared, or let me write this down here. Tan theta is nothing but sine theta divided by cos theta. So that's going to be 1 positive sine square theta divided by cos square theta. 1 positive sine square theta over cos square theta times d theta as integral d theta positive sine squared over cos squared times d theta. Now I will show you how to integrate this. This is straightforward. So let me consider integral sine squared theta over cos squared theta times d theta. I'm going to rewrite this as sine theta over cos squared theta times sine theta d theta. I will be employing integration by parts technique. So the formula is uv negative integral v du. This is u dv. So I need to take u. I'm going to take u to be as sine theta and dv to be as integral sine theta over cos squared theta times d theta. So my dv is sine theta divided by cos squared theta. So we need to integrate this to get the value of v. Now when you differentiate this, du is cos theta d theta. Now I need to obtain the integration of this. Now to obtain the integration of this, I can take cos theta to be equal to some u, and if I were to differentiate this, I get negative sine theta d theta is equal to du. So sine theta d theta is equal to negative du. So this is equal to integral negative du divided by u squared, which is nothing but negative u power negative 2 times du, which is negative 2 positive 1 divided by negative 2 positive 1, which is negative of u raised to the power negative 1 divided by negative 1, which is negative will give you positive. So this is 1 over u, right? But my u is cos theta, so just place cos theta. So what is this? All these things have been done to get the value of v. So v is obtained. So substitute it in the formula. So this is equal to uv. My u is sine theta and my v is cos theta, negative integral my v. What do I get for my v? My v is cos theta, 1 over cos theta, right? So 1 over cos theta times du is cos theta d theta. They get cancelled, giving me sine theta over cos theta, tan theta, negative integral d theta. So this is going to be tan theta, negative integral d theta is theta. So we have got this. What is this? This is nothing but integral sine square theta over cos square theta times d theta. So we need to take this value and substitute it here. So let me do that. So this is equal to integral d theta is theta followed by this value tan theta negative theta. So this and this gets cancelled, giving me tan theta. So that would mean, what did I do here? I have just shown you how to integrate integral secant squared theta d theta, which is tan theta. If you remember, we started off with I being equal to secant cube theta d theta. Then I wrote this as secant theta times secant squared theta d theta. Then I took the value of u to be as secant theta and dv to be as secant squared theta d theta. I need to get the value of v. So integral of secant squared theta is tan theta. So I have shown you how to get this. And in case of u being equal to secant theta, we need to get du. Du is secant theta tan theta times d theta. I also showed you how to differentiate this. So now coming back to our uv negative integral v du formula. So this is going to be u secant theta my V is tan theta, and my V is tan theta, my du is secant theta tan theta d theta. On the left you got I. Okay, now this is equal to secant theta tan theta negative. I'm going to multiply these two and I'm going to write it as tan square theta d theta. Now secant square theta negative tan square theta is equal to 1, and I can write secant square theta negative 1 is equal to tan square theta. So in place of tan square theta I'm going to write secant square theta negative 1. So I got secant theta times secant square theta negative 1 times d theta. This is secant theta tan theta. I multiply these two together, I get integral secant cube theta d theta negative negative positive integral secant theta d theta. Over here this is secant theta tan theta. Over here I've got I, but I've taken I to be as secant cube theta d theta, integral secant cube theta d theta. So this is going to be an I here. So I push this to the other side, I get I positive integral secant cube theta d theta is equal to secant theta tan theta plus integral of secant theta, that is going to be ln modulus of secant theta positive tan theta. We know this is by formula. If you're not sure that this produces this, I put a link of how exactly to evaluate this. Please watch that. Now this is I, so this is 2 times I is equal to secant theta tan theta plus ln modulus secant theta plus tan theta. Now push this 2 down, so this is going to be 1 over 2 times secant theta plus times tan theta plus 1 over 2 times ln modulus secant theta plus tan theta. So this is for secant cube theta. Now, but this is not the question. This is just part of the question. So let me just go back and show you the question. So this is the solution for integrating integral secant cube theta d theta. Okay. So let me come back to the question. This is the question. We are expected to integrate integral root of 1 positive x squared times dx. I made the substitution, and I have actually encountered a quantity like this. Okay. Now what I'm going to do is, whatever value that I have got, I would have to substitute it here. So let's do that. So in place of secant cube theta, we can substitute this. So I'm going to make that substitution. So this is equal to 1 over 2 times secant theta tan theta plus 1 over 2 times ln modulus of secant theta plus tan theta. This is what we have got. Now I've taken x is equal to tan theta. So this means tan theta is equal to x over 1. You draw the famous right triangle. Now this is theta, this is opposite side, this is adjacent side, this is hypotenuse side. Now tan theta is x over 1. If I were to square this, I would get x squared positive 1 squared is equal to hypotenuse squared. So this is going to be hypotenuse squared, but we need only hypotenuse. So this is going to be root of hypotenuse. In other words, this is hypotenuse is going to be root of x squared positive 1. So this is going to be x squared positive 1. Now we already have tan theta here, but we need secant theta. Now how do we get secant theta? Now secant theta is equal to 1 over cos theta. That's nothing but 1 over, take the value for cos theta, which is 1 divided by root of root of x squared positive 1. If you flip this, you get root of x squared positive 1 to be equal to secant theta. That's the value. So substitute these values here. So this is equal to half times square root of x squared positive 1 times x positive 1 over 2 times ln modulus root of x squared positive 1 positive x. Now you can rewrite this as 1 over 2 times. In fact, you can either place x here, or you can write this as x times root of x squared positive 1 positive. Now this can be just simply rewritten like this: 1 over 2 times ln modulus of x positive root of x squared positive 1 positive arbitrary constant c. So that completes the solution for this beautiful question. I hope you enjoyed this question. Until we meet again, like, share and subscribe to our channel. Thank you everybody.